Okay, so we're talking about logs, but they're really exponentials in a different form. So would you please rewrite this as an exponential? So what did you get? A to the C equals. And that's going to be a reminder that that's the what? The base. What's that? The exponent. What's that called? The argument. Good. You need to know all those terms. Next thing, A and B have to be certain kind of numbers. What kind? Can't be zeros. Good. What else can't they be? Negatives. Can't be negatives. And one of them can't be 1 and one of them can. Correct. Can't have a 1 down there, but I can have a 1 up here. So if I had this to be like 5 and this to be like a 1, I'd like you to prove to me, using exponentials, that that would have to be 0. Prove to me using an exponential that that has to be a 0. Somehow that doesn't look like the notes. What are you doing? Well, that's the main thing you do to prove it, except you got to go a little bit farther. Think for a second. What would C have to be to make this work?
0.
C equals 0. All right, so that's a very, very simple proof. Okay, but I want you to get the idea that whenever you have a problem that you're not sure about, because you might forget, you know, like let's say it's like this. And you're like, I don't remember how to do this one. You always can start by setting it equal to x and then rewriting it. Would you please do that on this one? I know that you probably, if you know what's going on, you know the answers too. I'm not trying to get that. I'm trying to get you to practice rewriting. Because see, they don't sometimes have another side. But you can make the other side by saying equals x. And then I go 5 to the x equals 25. And then how do you solve that? Well, you can just say, well, x has to equal 2. That's true. But if I make that 25 into what? A 5 what? Squared. Then these bases can cancel and x equals 2. Get that? All right. Next thing, let's try a little harder one. Log base 1/2 of 32. These are the hardest kind. It's where they have a fraction, and you're trying to make this whole number turn into a fraction. Because see, if this said log base 1/2 of 1/2 to the 5th power or something, then the answer would be 5. So I just got to rewrite that 32 as 1/2 to the something. So I'd encourage you to write it this way, and then just figure out with guess and check what you'd have to put it to.
-5.
Sonny's on top of it. -5 is correct. Now, if you're stuck on this kind, the first thing you should do is find a number that makes it bigger. Don't worry about the negative. Just make it big enough so that it gets close. Like when I put a 5 here to the 5th power, that means 1 over 32. And now I know I'm really close. It's got a 32 in it, at least. And then try making it negative if you need to. Because a lot of times the fractions ones will be like that. Okay, let's try a harder fraction one. Log base -3 of 1/8. Why the crinkly nose? It's impossible, yes. Why waste your time on this problem? Ah, because there's a negative in the base. So right away, what's the answer? Undefined would be a good way to say this. The argument? Nope. The argument can be a decimal. The base can be a decimal. Decimals are okay. What you can't have is negatives, and you can't have 0, and you can't have a 1 here. But decimals are all right, or fractions. All right, let's try another one. Log base 3 of 27. Nope. The base and the argument, both of these cannot be negative. The exponent can be negative, like the answer to it at the end. That can be negative. Got an answer? Tell me what's right. No, not 3. 3 to the x. Okay, this was a 27. I want you to rewrite it as, there you go. So now the answer is 3. All right. So I know you said 3, but the point is I was trying to get you to say what is 27. 27 is 3 to the third. All right, so how about if we had log base 2/3 of 27/8? Try that one. Do you get you just rewrite this as 2/3 to the something? Negative something. What do you think? -3 is correct. First of all, the third power brings them up to 8 and 27, or sorry, 8 and 9. No, I'm wrong. Brings them up to, yeah, 8 and 27, that's right. And then to get it to flip, I make it negative. And now, my answer is -3. All right, now here is where you'll have the problems that look really complicated, but aren't. Try that one. Now, some kids try to solve this a really complicated way that's right, but really complicated. They say 2/3 to the 4x plus 12 is equal to 27/8. That's a tough way to do it, but it could be done. The smart way to do it is, didn't you just seconds ago figure out that this whole left side was equal to what? -3. And what that means is you can replace this with -3. You see what I mean? So that's all there is to it. You just replace this whole thing with a -3. That's what that means. It's not just like the answer will be it. You can replace the whole thing with -3. If you were to type it in a calculator, it would come out to -3 on that side. Okay, so now you go -12, and you got -15 equals 4x. Final answer is x equals -15/4. Question? Okay. That's about as hard as they get. All right. Any questions? Any last questions? Anyone? Anyone? Bueller? All right. Then, would you please turn to the Schoology page and take the little practice quiz. It is called Revised. Yes, do the one called Revised because it'll work better. There's a quiz in Schoology. It's not a Skyward quiz. It's a Schoology quiz. You touch on it and then you start taking it. And you type in the answers. Now, there is 2 of them there. You want the revised one. When you're in the middle of the questions, look in the directions. If it says you can use a calculator, use a calculator. And one last thing I didn't talk about much, and I want to tell you one last free hint. If you have to figure out log base 4.8 of 29 with a calculator, you got to do what's called a base change. You just type in log 29 over log of 4.8. That's called a base change. That changed it from a base of 4.8 to a base of 10. Do you get what I mean? Because when you type this in the calculator's doing base 10. All right. So that's how you put in those on the calculator. I hope you already knew that, but there you go.